All right, welcome back, Hononegah Honors, Algebra 2. Section 10.5 is about permutations and combinations. This is actually one of the bigger lessons dealing with how many different ways can something occur. And so a permutation is the arrangement of objects in which the order is important, and I can't stress that enough. A permutation, the order matters. For instance, the 6 possibilities are, for this particular situation, with a permutation is AB, BA, AC, CA, BC, and CB. So 3 letters can actually be done, if I want only 2, 6 different ways if the order matters. If so, in this case, I have the word July, and I want to do how many different ways can you arrange the letters July in which the order matters. So July, spelled just the way it's supposed to be spelled, but then let's start scrambling up the letters. So if the J is first, and so hold on just a second, I'm going to go back here. So if the J is first and the U is second, then that's 2 different ways. So if the J is first and the Y is second, there is 2 different ways for that one. And if the J is first and the U is second. So as you can tell, you can start scrambling up these letters, and that one is just with the J first. So now what if I had the U first and the Y first and the L first? So there's 6 different ways each time you put the first letter then as the different letter. So again, how many different ways could you actually do this? So you're talking about 24 different ways if the order does matter. Now, how many ways can you do this if you just want 2 of the letters? So like a J with a U, a J with a L, and a J with a Y. So that is all the ones with J being first. So now if U is first, and what if the L is first? And if the Y is first? So if you're only going to have 2 of the letters, now that rules down the possibilities. Instead of having all 4 letters, now you only have 2 of the letters, and so now you're only talking about 16 possibilities, and I added that up wrong. Sorry. 12 possibilities if you only want 2 of the letters. So as you can see, permutations is if you want to. I messed up here, and I don't know how many people. I did the U second, and it should have been the L second here. The answer is correct. There you go. There are 24 possibilities up there, but I should have went J with a U, J with a Y, and then J with the L. So again, what is the different ways that I can spell words? Think about that. With only 4 letters, there was 24 possibilities of scrambling up those letters. Now, there is a formula to permutations, and this formula will be given to you. The permutation, we have to talk about what's known as a factorial here. So 4 factorial. It's an exclamation point. So it's not screaming the letter 4. It is 4 factorial, which means 4 times 3 times 2 times 1. And there is a factorial button on your calculator. So let's pull out a graphing calculator so that I can show you that button. So if you pull out a graphing calculator, you're looking for a factorial. And so if I want 4, under math, number, oh, sorry, probability, there it is. Math all the way over to probability, it's number 4. So you're talking about 4 factorial. And so this is taking 4 times 3 times 2 times 1, which is 24. So when we did that question about July, in which we had 4 numbers, 4 factorial is technically anytime you want to arrange something and you want to arrange the entire amount of values, it's that number factorial. So heading back over here. So that's what this first one is saying to you. Anytime you want the probability of n numbers in n order, then you're doing n factorial. Now, what happens though if you only want a certain amount? So the second question that we asked there was, you want 4 letters and you only want to use 2 of those. And so if you have 4 letters, but you only want to put 2 of them, it's 4 factorial divided by 4 minus 2 factorial. And that is the formula that will be given to you. And we'll have at least one question on the test that you will have to actually show your work here. And again, this formula will be given. And so what this is doing is taking 4 times 3 times 2 times 1. Now you technically don't need the 1. Times 2 times 1. And so what ends up happening is these two cancel, leaving you with 4 times 3. But again, this can be done on your calculator again. So let's go back to our graphing calculator and show you where that is. So if I go to my calculator, and again, I'm going to go to math, arrow over to probability. And notice you see NPR, so I'm going to hit number 2 there. And depending on how old or new your calculator is, you might have to hit the 4, then math. So 4, a permutation of 2, and you're going to get 12, which is what we already showed. Now, using the formula, so this is where I'm talking about. This is on the test. 8 factorial over 8 minus 5 factorial. 8 times 7 times 6 times 5 times 4 times 3 factorial. And notice that I stopped at the 3 because all of a sudden when you do 8 minus 5, you're going to get 3 factorial. So cancel those out. And so now without actually using the calculator to find 8 factorial, 8, a permutation of 5. Now I can just go 8 times 7 times 6 times 5 times 4 on my calculator, and it's 6,720. I'm going to do it on the calculator just to show you. But on your test, this is what I want to see. When I say using the formula, I want you to show that step. I don't care if you go straight from here to here. You don't have to show that second step, but you do need to show that you understand where the numbers go in the formula. So let's use the calculator on this one. I'm going to go math, probability, and I'm choosing a permutation. So I want 8 and 5 spots. So that means it's like saying I have 8 letters, and I want to arrange them in using only 5 of the letters, but how many different ways can I arrange those 5 letters? And it's 6,720 ways. 10 horses are running in a race, and how many different ways can the horses finish first, second, third? Assume there are no ties, and order matters, right? Because only one horse can finish first, one horse can finish second, and one horse can finish third. So this is a permutation because the order matters. 10 horses, and we're doing 3 places. So you can use a calculator here. I'm not going to in this particular one. So that's 10 factorial over 10 minus 3 factorial. 10 times 9 times 8 times 7 factorial, because I don't need to go any further. That's going to cancel, leaving you with just, and that's a bad 9, 10 times 9 times 8, which is 720 different ways that you can get 3 horses to finish first, second, and third. There are 10 members in a club, and the club needs a president, a vice president, a secretary, and a treasurer. How many different ways can you fill these positions? So again, 10 permutation of 4 spots. 10 factorial over 10 minus 4 factorial using the formula. So I'm going to cancel out the 6 factorial, and now we're talking about what do we have? There we go. 5,040 different possibilities there. For a town parade, you want to ride in the float. You will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the cheerleading float is second. So now, how many different ways can these 12 floats be arranged? And this is quite large, by the way. So this would be 12 factorial. So I'm going to have to pull out a calculator here, or we'll just leave it as 12 factorial for right now. Now, probability of successful items over total. So this is the total number of different ways that you can arrange 12 different floats. With that being said, now, how many is success? Well, if I'm first, or the float that I am on is going to be first, and the cheerleading float is going to be second, and then you can arrange the rest of the floats in any order we want. So that is, this float's first, this float's second, and 10 factorial. So now, all we're down to then is 10 factorial over 12 times 11 times 10 factorial. And again, I can cancel that out, which makes 1 out of 132 is the probability that you will actually get your float, the cheerleading float, and then the rest of the floats. Combinations are when the order doesn't make any difference. For instance, if you order sausage, then pepperoni, and then mushrooms, the order doesn't matter if you say mushrooms, sausage, then pepperoni. That doesn't make any difference. So it's a selection of objects in which the order is not important. For instance, in drawing 3 identical prizes, you would use combinations because the order of the winners would not matter. If the prizes were different, then that would be a permutation because the order does matter. So if I was just randomly choosing 3 winners, then that is a combination. But if I'm randomly choosing a first place, second place, and third place, then it's a permutation. So let's go back to the original situation. We're going to count the possible combinations of 2 letters from A, B, C, and D. So I'm going to do the permutation, and then we'll go from there. So A, B, A, C, A, D, B, C, B, A, and B, D. This is permutation now. C, A, C, B, and C, D. D, A, D, B, and D, C. So that's a permutation in which the order doesn't make any difference. Now, let's say I take out the ones then that are repeats. So A, B, and B, A are repeats if the order doesn't make any difference. Same with A, whoops, I was going to cross it off the other spot. Hold on. So AC and CA, AD and DA, BD and DB, and CD and DC, and then BC and CB. So if the order doesn't make any difference, then there's way less combinations that you're dealing with. You're talking about 6 combinations instead of, if the order doesn't matter, or excuse me, the order does matter, there's actually 12, and it's not always half, okay, so don't think of that situation, but there's way less combinations than permutations. Now, there is a formula that will be given to you. So going back to what we just did, a combination of 4 with 4 objects, only taking 2 at a time. You'll notice that the formula, 4 factorial over 4 minus 2 factorial, 2 factorial. So whatever the R is, goes in the bottom there twice. And you'll notice then the answer that I got when I did it by hand is correct. There are 6 different combinations. Using the formula now, so it's 10 factorial on top, 10 minus 3 factorial. So that part looks exactly like a permutation, except there's also a 3 factorial in there. So that is what you will have to show on your test. Now, calculating it, you can use a calculator if you want. 10 factorial is 10 times 9 times 8 times 7. And so these two are going to cancel each other out. 3 factorial. And so I can do some, and so I end up getting 120. I will use my calculator just to show you that it does work there. But the only thing you'd have to show is that you know where to put the numbers into the formula. So let's pull out a calculator. Again, under math, probability, you'll notice that number 3 is NCR, or combinations. So if I had 10 and I want 3 spots, I get 120. So notice that I showed that to you by hand, and also you're ordering a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations do you have? So 8 to choose from. Anytime you're kind of using the word choose from, like you're going to pick and the order doesn't make any difference. I'm going to do this by hand. 8 factorial, 8 minus 2 factorial, and 2 factorial. So 8 factorial on top. Let me try this again. 8 times 7 times 6 factorial. Notice that I just stop there because those two will cancel. 2 factorial is just 2, and so the answer to this is 28 different combinations of 8 dishes, you choosing 2. There are 9 books on the shelf, and you choose 4 to read with your sibling. How many ways are there to choose those 4 books? Now, you're choosing 4 at a time. This one's a little bit misleading because ultimately you would think you were choosing 1 at a time. They're saying how many different ways are there to choose 4 books at a time. So we're talking about 9 books. And so 9 times, oops, I'm going to write this out, sorry, 9 factorial. And you don't have to show this on here. 9 minus 4 factorial and 4 factorial. So you would not have to show it on this particular question. You can go straight to your calculator on this. 9 times 8 times 7 times 6 times 5. 4 times 3 times 2 times 1. 2 and 4 cancel out the 8. 3 cancels the 9. And again, I'm showing this by hand here, and you do not have to. 42 times 3. So you get 126. I am going to use the calculator here just to prove that I did it right. So I'm going to math, arrow over to probability, number 3. And so we're talking about 9 and I don't remember what it was. 4? Is that right? Yep, there it is. Last one. A yearbook editor selected 14 photos, including one of you and your friend, to use in a collage of the yearbook. The photos are placed at random. There's a room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top? So how many different ways can you get 2 photos out of 14? And the order doesn't make any difference. We just want 2 photos, so that's why it's a combination. So we're talking about 14 factorial over 14 minus 2 factorial, 2 factorial. And again, you do not have to do this by hand, but you're talking about 91 possibilities. Now, I want one scenario here. My picture and my friend's picture are at the top. So success would only be 1 out of the 91 different ways. Because again, we use combinations, not permutations, so the order doesn't matter, which is why there's only 91 possibilities, and I want that 1 possibility then. All right. Now, your homework assignment is on page 575. This may change, so please make sure that you look in the Google Classroom. There was a chance that we were going to do 2 assignments here. So please be aware of the fact that this may change. In fact, I know it does change. Sorry about that. It is going to be 3 through 33 odd and 37 to 40. So lots of questions there. Please make sure that you talk to your teacher, and good luck.